Hello everyone, this is Owen. I'm going to be walking you guys through my final project, which I created in a Jupyter Notebook, and I will be discussing college basketball, which I thought was fitting as we're getting into the thick of it here in March with conference tournaments coming up, and then the big dance, which gets everybody excited. So, as you guys may recognize from before or have just seen online, KenPom is the heart and soul of college basketball ratings, and I'm going to focus on their net rating, also known as the adjusted efficiency margin, which is simply the offensive rating minus defensive rating, and those two may be defined as points scored or allowed per 100 possessions, adjusted for the opponent. So all of my data I gathered from KenPom, which was through games from the start of this week, and it includes all college basketball teams from this year, NCAA Division One. So back to the Jupyter Notebook. So my research question that I want to answer is, how does KenPom Net Rating influence win percentage? And so I want to answer this question by doing a few things. First, I create a win expectation model. It's a linear model with win percentage as the dependent variable and net rating as the independent variable. And then I want to break down that question a bit further with partial regression plots, because net rating is a linear combination of adjusted offensive efficiency and adjusted defensive efficiency, or offensive rating and defensive rating. I might use those two interchangeably. And because net rating is a linear combination of those two, I break it down to see if those two predictors hold equal weight, which we imagine they should. Um, being points or no points is essentially the same. A bucket's a bucket, and a bucket prevented is, essentially the same thing. And um, we want to see if there's equal weight being picked up by the model there. And then I want to break down with conferences to see how those fixed effects are playing into our win expectation model. And then I'll dive in a little bit deeper into conference. Just getting excited for conference tournaments coming up to see where we might want to focus our attention, see where the best games are, and not only the best games, but the best competition. And we'll get into that shortly, but let's get started. So first, I'm just loading in all my packages and whatnot, and then I read in my CSV file, which I just copy and pasted from kenpom.com, and I create a win percentage column because the wins losses is recorded as a string. And so I just split it by the hyphen, expand it into two columns, and then make sure that I'm storing that as an integer so that I can divide and create this win percentage column in my data frame. And so here's a little snippet of the data here. It's just like what we saw on the website: teams, conferences, win losses, net rating, offensive rating, and defensive rating. And then we have ranks and tempo as well, but we're not really going to be getting into that. And the strength of the schedule is here, it's isolated as its own predictor, but that's included in the adjusted efficiency metrics there. So, and then we have the win percentage column that we just created. And then I'm going to create a scatter plot with a best fit line. See net rating on the x-axis, win percentage on the y. And we see a decently tight fit, but it sort of drops off at the bottom here. So we'll be looking into that with our linear model. So here, simple linear regression using OLS, and then we have our regression results, and we see R squared 0.607. So positive correlation, as we can see in the plot here, moderately moderately positive, not too strong, but definitely a relationship here to be explored. And then we're just going to quickly look at our assumptions. Durbin-Watson, we want to see about 2. 1.804 is looking great there. So that's measuring for, it's running a test for independence. And then we have the Yark-Bera test, which is for normality. So that's our statistic right there. And then we have the p-value for the Yark-Bera test, which is outside of the rejection region. And that's all good. That means we've got independence, normality, and linearity. And then lastly, we have our residuals versus fitted chart, and we see no pattern here. Looks random, which is good. That's what we're looking for. And so that confirms that we don't have homoscedasticity, or excuse me, we don't have heteroscedasticity. We do have homoscedasticity, equal variances. So that's all good. And then let's look at the regression results a little bit closer, specifically our coefficient. So our intercept is about 0.5. That's what we'd expect. A team that has adjusted efficiency margin of 0, meaning their points scored minus points allowed per 100 possessions. If that's 0, we'd expect them to be about 500. It's a little bit higher, but nothing to raise our eyebrows at. And then we see our net rating is about 100th. So this means that if we were to increase net rating by 1 point, so we have 1 point, 1 point scored more than points allowed, we would expect on average win percentage to increase by 100th. So let's just keep that in mind as we move forward. But that's our win expectation model. So next, we want to break this down into offensive rating and defensive rating. And these being a linear combination of, adjusted efficiency margin is a linear combination of offensive rating and defensive rating. It's just the former minus the latter. So we're going to look and see how our partial regression plots show the relationship between our independent variables and our dependent variable being win percentage while holding the rest constant. And so we have our partial regression plots down here, and we're just looking at the slopes of these two, and they seem to have about equal magnitude. And this is, like we said, what we would expect. And then looking closer at the regression results, we see that they're about the same. Offensive rating is just a little bit lower in magnitude compared to defensive rating. So this model just gives a slight edge to defensive rating of about 1,000th, which isn't too much concern here. And again, our R squared is positive. Actually, I think it's the same number, but that is what we would expect, considering these are just a linear combination of our prior independent variable. One thing I'd like to note here is that intercept seems to have something going on, and then this sort of segues into our fixed effects model, which is going to include conference as a categorical variable, and see how our model intakes that predictor and see what happens. So next, we include conference here with net rating. So we're back to just including net rating instead of the other two. And our R squared is higher, although R squared isn't the greatest thing in the world. Or at least it's not the most trustworthy. But again, good to see that we have a strong positive correlation here. And then as we look a little bit closer, we see all of these new predictors that we're using in our model. And this is just changing the intercept for each of these groups. And the way that we can interpret this is, and we've got net rating down there. The way that we can interpret this is for the teams that fall into these groups, what sort of shift is happening or what sort of penalty is happening um, when we're looking at the relationship with adjusted efficiency margin or net rating and win percentage. And, some of these conferences we're not all too familiar with, but, we can look at the ACC is negative, Big Ten is negative, Big 12, Big East, and then we've got the SEC down here, which is the largest magnitude, and also negative. So these power conferences are being penalized because once conference play starts, each team in these groups, one's going to get away with a win, one's going to come away with a loss. And so it's impossible for these teams to separate themselves at that point in the season. And so we can see then down here with our fixed effects plot, SEC, Big 12, Big 10, Big East are leading the way. And then there's a slight drop off. The ACC is not very good this year. And the Mountain West is pretty competitive. And the Western Conference is highly skewed due to St. Mary's and Gonzaga being highly consistent teams. And then I think Air Force has like one loss this year, so they aren't doing too hot. But yeah, so it makes sense to see this negative fixed effect because the teams are playing better competition. They're facing stronger teams throughout the week. So that's this is almost a way to look at a conference power rankings in a way. And then as we move on, we see the regression output, and then we want to come down here because I'm running out of time here, but the last thing I want to do is look at net rating spread by conference to see which conferences have the higher net rating mean, first quartile, third quartile. So I use boxplots for that to look at the distribution of net rating by conference. And we can see immediately that the Western Conference and Mountain West have high variance. The ACC has high variance here, with Duke being an extreme outlier this year. And then Big 10, Big 12, and SEC seemed a little bit more compact in Big East too, which suggests that those conference tournaments might be given priority in terms of watching for more competitive basketball because these teams are closely grouped in terms of net rating, whereas we might see more blowouts in the ACC, Western Conference, Mountain West, etc. And so lastly, just to complement this, because I've only got a minute left, I want to look at means and variances by conference and then complement that with some analysis of variance hypothesis tests. And so we can see the SEC has the highest mean net rating, followed by the Big 10, Big 12, and Big East. And so this is where you're going to get high-powered basketball. And then the variance tells us how close the competition is going to be in those conference tournaments. And we see SEC, Big 12, Big East, and Big 10, especially the Big 10, is going to be very, very competitive. I'm excited to watch Big 10 conference tournaments. And then lastly, I just run two quick analysis of variance hypothesis tests. The first one, I included the top four conferences seemingly from our results, so excluding the ACC and the Mountain West, and we see significant results that these groups have different means. And then lastly, I just look at the top three, and the results aren't as significant, but it tells us that the Big East is a little bit